Hello. Today, we're going to explore the concept of isolation. Isolation, in a general sense, means separating or segregating something from others. However, its specific meaning and the types of isolation can change a lot depending on the field we're talking about. Let's dive into some of the most common contexts. First up, let's look at isolation in healthcare and medicine. Here, isolation refers to specific measures taken to prevent the spread of infectious diseases. It involves separating people with contagious illnesses from those who are not infected. There are several types. Contact isolation is used for infections spread by touch, like MRSA. Healthcare workers wear gloves and gowns. Droplet isolation is for infections spread by respiratory droplets, like the flu. Wearing a surgical mask is necessary. Airborne isolation is needed for diseases spread through the air, like tuberculosis or measles. This requires a special negative pressure room and an N95 respirator. Finally, reverse or protective isolation protects patients with weakened immune systems from germs. Next, let's consider isolation in psychology and sociology. Here, isolation refers to being separated from others, either physically or emotionally. It can be voluntary or involuntary. Social isolation is a lack of social contact and interaction. Emotional isolation is feeling disconnected, even when around others. Self-imposed isolation is choosing to be alone. Forced isolation happens due to external factors like quarantine or imprisonment. Now, let's switch gears to electrical engineering. Here, isolation means separating electrical circuits to prevent unwanted current flow or protect users. Galvanic isolation uses a physical barrier, like a transformer or optocoupler, to stop direct electrical connection, protecting against high voltages. Other types like basic, supplementary, and reinforced isolation refer to different levels of insulation providing increasing degrees of protection. In chemistry and biology, isolation is the process of separating a specific substance or organism from a mixture or its environment. Chemical isolation involves techniques like distillation or chromatography to purify a compound. Microbial isolation means getting a pure culture of a microorganism, often using agar plates. Genetic isolation prevents gene flow between populations, leading them to evolve differently. In computer science, specifically databases, isolation ensures that multiple transactions happening at the same time don't interfere with each other. There are different isolation levels, like red committed or serializable, which offer varying degrees of protection against interference, ensuring data integrity. Finally, in engineering and mechanics, isolation refers to methods used to reduce the transmission of unwanted vibration, noise, or heat. Vibration isolation uses special mounts to stop machine vibrations from spreading. Acoustic isolation uses soundproofing materials to block noise. Thermal isolation uses insulation to reduce heat transfer. So, as you can see, isolation is a versatile term. While the specifics change, the core idea remains the same: creating separation for a specific purpose, whether it's safety, purity, privacy, or functionality. Understanding the context is key to knowing what kind of isolation is being discussed.